Look at this image. You have likely seen it hundreds of times. This is the Hubble Ultra Deep Field, humanity's deepest gaze into the abyss. In this tiny patch of sky, there are thousands of galaxies, spirals, ellipses, ancient clusters of stars. Every dot here is an island inhabited by billions of worlds. When we look at this image, we feel a sense of awe. It seems to us that we are seeing the universe exactly as it is, vast, rich, filled to the brim with matter. It seems that our telescopes have finally torn the veil from the cosmos and shown us the complete picture of creation. But this impression is a profound delusion. This image is not a map. It is a keyhole. Imagine you have lived your whole life in a tightly sealed room without windows, and one day you found a tiny crack in the wall. You pressed your eye against it and saw a small piece of a green leaf. And based on this, you decided that the entire world consists only of greenery. You didn't see the sky. You didn't see the sun. You didn't see the concrete of cities or the water of oceans. This is the position humanity finds itself in right now. Let's look at the figures. Astronomers estimate that there are about 2 trillion galaxies in the observable universe. 2 trillion. That is a 2 followed by 12 zeros. Now, the question: how many of them have we mapped? How many have we actually seen, cataloged, and studied? A few million. If we translate this into percentages, we have seen less than 0.01% of what actually exists. More than 99.9% of the cosmic structure remains invisible to us. We are behaving like a tourist who steps onto the porch of a hotel, takes a picture of the front door, and claims to have explored the entire country. And the most terrifying thing here is not that we have seen so little. It is why we haven't seen it. We are used to thinking that this is a question of technology, that we just need to build a bigger telescope, launch the James Webb, wait another 10 years. But physics tells us otherwise. The universe is designed to hide its secrets. Distance grinds galaxies into dust. The expansion of space stretches their light into total invisibility. Huge clouds of gas block our view like heavy curtains. And beyond a certain line, light simply ceases to reach us at all. Today we will not talk about what we can see. There will be no pretty pictures from Hubble. Today we will talk about what is hidden from us. We will try to feel out the shape of the dark room in which we are locked. We will dissect the anatomy of our blindness, and the first obstacle on the path to truth lies not billions of light years away. The first reason we don't see the cosmos is our own home. When you look at the night sky far from cities, you see the Milky Way, this majestic glowing band that crosses the firmament. Poets have sung its beauty for centuries. The ancient Greeks believed it was the spilled milk of the goddess Hera. But for astronomers trying to map the universe, the Milky Way is not beauty. It is a curse. Imagine trying to see a forest through a window, but the glass is thickly smeared with white paint. You can see the trees to the left, you can see the trees to the right, but right in the center of your vision is a dead zone. We live inside a galaxy shaped like a flat disk, and we are located inside that disk. When we look up or down relative to the plane, the view is open. But when we look along the plane, our gaze hits billions of stars and, far worse, clouds of interstellar dust. This dust works like a smokescreen. It absorbs visible light coming from the depths of space. Astronomers have given this phenomenon a name that sounds almost ominous: the zone of avoidance. This is not a small patch of sky. The zone of avoidance blocks about 20% of the entire celestial sphere from our view. 1/5 of the observable universe is simply crossed out from our maps. Imagine a map of Earth where all of North America and part of Eurasia have been blacked out with a marker. That is what our maps of galaxies look like. There is simply a void. But this void is illusory. Giants are hiding behind this curtain. For a long time, we thought our local group of galaxies was a quiet place: Andromeda, the Milky Way, and a few dwarfs. But when scientists began scanning the zone of avoidance in the radio spectrum, which can pass through dust, they were horrified by what we had been missing. It turned out that right under our noses, hidden by the dust of the Milky Way, hang massive galaxies. For example, Maffei 1 and Maffei 2, gigantic structures whose existence we didn't even suspect until the late 20th century, simply because they were hiding behind our own backs. But the most unsettling discovery lay ahead. Astronomers noticed a strangeness in the movement of our galaxy. The Milky Way, Andromeda, and all our neighbors are flying through space in one specific direction. Something is pulling us. We are flying there at a breakneck speed, more than 2 million kilometers per hour. To create such a gravitational pull, something colossal must lie ahead. An accumulation of mass equal to tens of thousands of galaxies, a gravitational monster capable of attracting entire sectors of the universe. Scientists named this place the Great Attractor. And by a twist of fate, the Great Attractor is located right in the center of the zone of avoidance. The most massive and influential object in our local neighborhood is hidden from us by the densest part of our own galaxy. We are hurtling towards something gigantic, but we cannot see exactly what. We feel the gravity, like a blind man feels the heat of a fire, but we do not see the flames. Of course, modern X-ray telescopes have helped us peek behind the curtain a little. We found the Norma cluster there, but the full picture is still blurred. We are like passengers on a train rushing into a tunnel, not knowing if there is light at the end. However, the zone of avoidance is merely a physical barrier. It is dust on the glass. But what if the objects we look at in the clear sky refuse to shine on their own? Even in those parts of the sky that are crystal clear, we still miss the majority of inhabitants. In science, there is a concept called selection bias. Imagine you are studying the ocean using a net with 10-centimeter mesh. You cast the net, pull it out, and see only large fish. Tuna, sharks, large cod. You write in your journal, only giants inhabit the ocean. Small fish do not exist. Absurd. Of course, but that is exactly how we have studied the cosmos for the last 100 years. Our telescopes are designed to catch light, bright, concentrated light. When we tune our optics, we look for objects with high surface brightness. We look for galaxies where stars are packed tightly, like lights in the center of a metropolis. And we find them. The spirals of the Milky Way, the bright ellipse of Andromeda. We built a model of the universe based on these beacons. But recently, astronomers began to suspect something was wrong. What if we are seeing only the tip of the iceberg? What if most galaxies are not bright metropolises, but dim villages whose light simply doesn't break through the noise of our sensors? Thus, low-surface brightness galaxies were discovered, or ghost galaxies. Look at Dragonfly 44. If you were flying near it, you might not even realize you were inside a galaxy. The stars there are scattered so rarely that the sky seems almost empty. But this is not a dwarf. In mass and size, Dragonfly 44 is comparable to our Milky Way. It is a giant, but it has 100 times fewer stars than we do. The rest of the mass is dark matter. It is a huge, heavy, invisible monster, barely sprinkled with a handful of dim stars, and such objects were right under our noses. We looked through them for decades, considering them just noise in photographs or defects in the film. This changes everything. For a long time, we looked at dark patches of the sky, the so-called voids, and thought there was nothing there, just millions of light years of vacuum. Now we are beginning to understand. There is no void. It is filled with ghosts. There's a class of objects called ultra-diffuse galaxies. Imagine you took the entire population of New York and scattered it across the entire territory of Eurasia. The population density would drop almost to zero. The city would disappear, even though the people didn't go anywhere. The same thing happens with these galaxies. They are stretched, blurred, ephemeral. And this scares theorists, because our current estimates of the number of galaxies, those 2 trillion, are based on what we have already seen, plus extrapolation. But if the universe is teeming with ghost galaxies that our telescopes physically cannot register because of their dimness, then the real number could be tens of times higher. We live in a crowded room, but we hold only a weak candle that illuminates the faces of only those standing right next to us. The rest stand in the shadows, watching us. We miss them because they are too diffuse, too smeared across space. But there is another kind of invisibility, more fundamental, more hopeless. Some galaxies are invisible not because they are dim themselves. They can shine like thousands of suns, but between us and them stands a barrier that cannot be overcome simply by improving camera sensitivity. This barrier is time and space itself, and it steals light from us in the most sophisticated way. We are used to thinking that the cosmos is static, that stars are nailed to the firmament like light bulbs to a ceiling. But the universe is not a ceiling. It is the surface of a balloon that someone is continuously inflating. In 1929, Edwin Hubble discovered something that overturned physics. He saw that almost all galaxies are moving away from us. But there is a nuance here that is hard to wrap your head around. Galaxies are not flying through space like rockets. Space itself is expanding between the galaxies. Imagine you drew two dots on a rubber band. Now you start stretching it. The dots don't move along the rubber. They stay in their places, but the distance between them grows. And here begins the tragedy of light. Light is a wave. It has peaks and troughs. When light flies out of a distant galaxy, it may be bright, blue, full of energy, but it faces a long journey. For billions of years, it flies through the void to Earth, and all these billions of years, the space underneath it stretches. Along with space, the light wave itself stretches. Its peaks get further and further apart. In physics, this is called redshift. Blue light turns into yellow, yellow into red, and red goes into the infrared range. And here is the problem. The human eye does not see infrared light. Our best optical telescopes, like Hubble, go blind when they try to look too far. For us, these distant galaxies simply disappear. They switch off. Right now, billions of worlds are sending us their signals. They are screaming into the void. But by the time their scream reaches Earth, it becomes so low and stretched that we no longer hear it. It turns into radio waves or faint thermal radiation. It's not just that galaxies are moving away. It is space itself creating new void between us every second. The further the object, the faster it runs away. That is precisely why we built the James Webb telescope. It is our night vision goggles. It sees in the infrared range. It returned a part of the lost universe to us, showing ancient galaxies where there was previously only blackness. But even James Webb has a limit. The expansion of the universe is ruthless. The further we look, the faster the expansion carries objects away. At vast distances, the speed of the expansion of space begins to exceed the speed of light. This sounds like a violation of the laws of physics, because nothing can move faster than light, right? Wrong. Nothing can move through space faster than light, but space itself can expand at any speed, even 1,000,000 times faster. And this creates the ultimate prison wall for us. There is a boundary beyond which light is so stretched and travels through space expanding so fast that photons simply physically cannot reach us. They are like a runner on a treadmill that is moving backward faster than he is running forward. This runner will never reach the finish line. The light will never hit the lens. We call this the cosmological event horizon. And this is the edge of our world. In astronomy, there is a term that is more misleading than any other. That term is the observable universe. When we hear this, we imagine a sphere. The boundaries of this sphere are defined by the oldest light that has managed to reach us since the Big Bang. The radius of this sphere is about 46 billion light years. It seems like a lot. It seems like a huge stage. But the truth is that the observable universe is not the whole universe. It is just a tiny spot of light in an infinitely dark forest. What lies beyond this boundary? According to the theory of cosmic inflation, the most reliable model of the birth of the cosmos we have, the universe continues beyond our bubble. There are the same galaxies, the same stars, perhaps the same observers looking into their telescopes and thinking they are the center of everything. But we will never know about them, and they will never know about us. We are separated not just by distance, we are separated by causality. Imagine an ant crawling on the surface of a balloon. If the balloon inflates fast enough, 2 points on its surface begin to move apart faster than the ant crawls. Even if the ant crawls forever, it will never reach the second point. Light is that cosmic ant. It has a speed limit, but the expansion of space has no limit. This creates a terrifying situation. Right now, at this very second, galaxies are crossing an invisible line called the cosmic event horizon. The moment a galaxy crosses this line, it doesn't explode. Nothing happens to it. But for us, it dies. The last photon of light it emitted before crossing will reach us billions of years from now, but a photon emitted a second later, never. It will fly forever through space that stretches before it faster than it can overcome. It is a point of no return. If you were to leave Earth right now at the speed of light to catch up with these galaxies, you would still lose the race. Space is being created between you and your target faster than you can devour it. You would fly forever into the void, but never see the shore. Scientists have calculated that if the global universe is indeed infinite, or at least simply very large, then the observable universe, the part we can theoretically see, makes up a negligible fraction of a percent of reality. We are like a fish in an aquarium thinking that the glass walls are the end of the world. But beyond the glass lies an ocean the fish cannot even imagine. And the saddest part is how this looks to the observer. Galaxies passing beyond the horizon do not disappear instantly, like a switched-off light bulb. Due to time dilation and redshift, their image will freeze for us and slowly fade. We will see their ghostly reddened light for billions of years more, watching their distant past. But their present is already cut off from us forever. We live in a bubble of loneliness, and this bubble loses information with every moment. But let's return inside the bubble. Suppose we accept that we cannot see the outer lands, but what is here, right next to us, do we see that well? Again, no. Even here, inside our observable horizon, 85% of matter is absolutely invisible. We see galaxies, stars, and gas. But all this is just thin skin on the body of a giant. The skeleton that holds the entire structure is hidden from the eyes. Imagine you are looking at a children's merry-go-round. It spins faster and faster. At some point, the speed becomes so high that the children should simply be thrown outward by centrifugal force. But for some reason, they stay in their seats. They hang in the air as if glued. This contradicts the laws of physics. If there are no ropes holding them, they must fly away. In the 1970s, astronomer Vera Rubin saw exactly this picture in space. She studied how spiral galaxies rotate. According to the laws of Kepler and Newton, stars at the edges of a galaxy should move slower than stars in the center. After all, gravity is weaker there. But Rubin saw the impossible. Stars on the outskirts were rushing at the same insane speed as in the center. Galaxies were spinning so fast that they should have torn themselves apart. Stars should have flown off into the void like stones from a sling. But the galaxies remained intact. The only explanation for this phenomenon sounded like science fiction. The galaxy we see is not the whole galaxy. What glows, stars, gas, dust, is only a tiny part of the mass. Everything else is hidden. We realized that the universe is filled with an invisible substance. We named it dark matter. But this name is deceptive. It is not dark in the usual sense, like shadow or soot. It is something that does not interact with light at all. It doesn't reflect it, doesn't absorb it, and doesn't emit it. It is transparent to light, like glass, but it possesses gravity. The best metaphor to understand our situation is flying in a plane at night over a continent. You look out the porthole and see city lights below, bright patches of metropolises, thin threads of highways. If you are an alien who sees only light, you would decide that Earth is an archipelago of glowing islands in a black ocean. You don't see the land. You don't see the mountains, fields, and foundations of buildings. But it is this invisible land that determines where the lights will burn. Cities are built where there is land. In space, the role of land is played by dark matter, and galaxies are just street lamps placed on the hills of this invisible terrain. Computer simulations, such as the Millennium Run, have shown us the true structure of the cosmos. If you remove the light and leave only the mass, the universe looks like a giant three-dimensional web. Huge, thick strands of dark matter intertwine, forming nodes and filaments. This is the cosmic web, the skeleton of creation. Ordinary matter, the atoms you and I are made of, stars, planets, simply drains into the gravitational wells of this web, like rainwater drains into gullies. There it accumulates, ignites as stars, and forms galaxies. If we could see gravity the same way we see light, the night sky would change beyond recognition. Instead of a black void with sparse points of stars, we would see a pulsating network. The sky above us would look like an interweaving of giant veins and arteries through which matter flows. We would see bridges between galaxies millions of light years long. We would see that we are not alone in the void, but firmly fused into a giant cosmic organism. But our eyes are blind to gravity. For us, this skeleton is invisible. We know about it only by indirect signs. We see how the light of distant galaxies bends as it passes through the void, as if a giant invisible lens hangs there. This is dark matter bending space itself with its mass. And this is even more frightening if you think about the fact that this substance is not somewhere out there. It is everywhere. Right now, streams of dark matter are passing through your room, through your body, billions of particles every second. But they don't touch your atoms. To them, you are a ghost, and to you, they are ghosts. Dark matter is the glue that holds the universe together. It tries to gather everything into a single lump. Its gravity pulls, compresses, builds structures. But there is a war raging in space. Against the builder stands the destroyer. And the destroyer is winning. Until the end of the 20th century, astronomers were sure of one thing: gravity would win. The logic was ironclad. The universe was born in the Big Bang, which scattered matter in all directions. But matter has mass. The gravity of dark and ordinary matter pulls everything back towards each other. We thought that over time, the expansion of the universe would slow down. Like a ball thrown upward, flies fast at first, but then breaks to fall back into the hand. But in 1998, astronomers looked at distant supernovae and realized that physics had gone mad. The ball didn't slow down. On the contrary, somewhere at the peak of its trajectory, it engaged a rocket engine and screamed into the sky, gathering speed every second. The universe is expanding with acceleration. Some unknown force is pushing galaxies apart, overcoming the full power of dark matter's gravity. We named this force dark energy. And if dark matter is the skeleton of the universe, then dark energy is the poison that kills this organism. It makes up almost 70% of all the energy in the cosmos. We don't know what it is, but we know how it works. Dark energy is a property of space itself. Unlike matter, which dilutes as it expands, dark energy does not weaken. The more space there is, the more dark energy there is, and the more of it there is, the harder it pushes the cosmos apart. It is a chain reaction, a self-sustaining explosion of vacuum, and the consequences of this process for the observer are tragic. Dark energy turns the universe into a place of absolute loneliness. It takes clusters of galaxies and drags them away from each other. The space between them grows so fast that light, as we've already discussed, ceases to arrive. This is not just expansion, it is the great eraser, methodically wiping out history. Right now, we live in an amazing era. We call it the era of stars. We see our neighbors. We see distant quasars. We see the cosmic microwave background, the echo of the Big Bang. The sky is full of information. But it won't always be like this. In 100 billion years, dark energy will have done its job. All galaxies not gravitationally bound to us tightly, like our local group, will be carried beyond the event horizon. Imagine the night sky of the future. The Milky Way has long since merged with Andromeda into one giant elliptical galaxy. The stars are aging and turning red. But most importantly, around this galaxy, there is nothing. Absolute, perfect blackness, no nebulae in the distance, no other galaxies in the telescopes. Even the most sensitive equipment will show only infinite vacuum. The rest of the cosmos will have flown away from us at speeds exceeding the speed of light and vanished beyond the edge of reality forever. And this leads us to the most disturbing thought of today's story. We are used to thinking that science is a process of accumulating knowledge, that tomorrow we will know more than today. that in 1,000 years we will solve all mysteries. But in cosmology, this is not the case. In cosmology, we are losing knowledge. Information is physically destroyed by expansion. Photons that carried data about the birth of the universe are stretched into a flat line. Galaxies that held the secrets of matter evolution fall out of our world. We lose bits of information every second. The universe we see today is poorer than the one that existed 1 billion years ago. And the universe of the future will be a practically empty book. And this poses a question that makes one's head spin. If future observers will see less, what if we, too, have missed something? What if in the distant past there was something important in the universe that disappeared beyond the horizon before we managed to build the first telescope? What chapters of cosmic history were torn out and burned before Earth even appeared? We will never know. But we can imagine what those who live after us will think of the world in the era of great loneliness. Let's conduct a thought experiment that scares many cosmologists more than black holes. Let's fast forward, not 1,000 years, but 100 billion years. Our solar system perished long ago, but our galaxy is still alive. True, it looks different. The Milky Way and Andromeda have finished their gravitational dance and merged into one giant elliptical galaxy. Astronomers call it Milkomeda. Imagine that in this new galaxy, near a dim red star, intelligent life arises. A civilization appears. They are curious, just like us. They build telescopes. They create physics. They look at the sky. What will they see? They will see trillions of stars in their own home, but outside their galaxy, they will see nothing. By this time, dark energy will have inflated the universe so much that all other galaxies will have gone far beyond the event horizon. Their light will never reach Milkomeda again. The cosmic microwave background, that very echo of the Big Bang that told us about the birth of the world, will stretch so much that it becomes physically invisible. Its temperature will drop to almost absolute zero. And here is the conclusion the scientists of the future will reach. They will look around and say, "We are alone. The entire universe is our galaxy. Around us is an infinite, static, eternal void. There is no expansion. There was no Big Bang. The world has always been exactly as it is now." And the scariest part is, their science will be flawless. They will conduct observations and the data will confirm their theory. They won't find redshift because they won't see other fleeing galaxies. They won't find background radiation. All evidence pointing to a dynamic, evolving universe will be erased by time. Their physics textbooks will be correct, their mathematics will be precise, but their picture of the world will be a monstrous lie. They will live in the illusion of an island universe, and they will have absolutely no way to know the truth. Unless they find records of some ancient, long-vanished civilization that lived billions of years ago. A civilization that managed to look at the sky in that brief moment when the cosmos was still visible. Us. This brings us to the dizzying concept of the privileged moment. We live in a unique time. We do not live too early when galaxies had not yet formed, and not too late when they have already disappeared from view. We live in the golden age of cosmology. The window of opportunity is open right now. We see the scattering of galaxies. We see the traces of the Big Bang. We have access to information that in the future will become secret, lost knowledge. But this thought works in reverse too. And that makes it unsettling. If future observers are blind to the Big Bang because of time, then what are we blind to? What if the universe has already gone through phases whose traces were erased 13 billion years before our appearance? What if there were structures, laws, or events that disappeared beyond the event horizon long before the first ape picked up a stick? We are proud of our knowledge, but perhaps we are just like the scientists of Milkomeda. We have built perfect theories based on what we see, but we see only the remnants of past greatness, scraps of reality. Perhaps the greater part of the universe's history is already irretrievably lost, not because we are stupid, but because we are late. We are standing on the platform of a station from which almost all the trains have already departed, We study the trash on the tracks and try to reconstruct the train schedule. This realization shouldn't be frightening, but sobering. It teaches us humility. We are not the masters of this knowledge. We are accidental witnesses. And this leads us to the final question. If we see so little, if we are locked in a bubble, if 99% of reality is hidden in darkness or carried away by time, then what is the point of looking? We started this journey with the metaphor of a keyhole. We talked about being locked in a dark room, and now, looking back at all the barriers physics has built before us, the dust of the Milky Way, invisible dark matter, accelerating expansion, the event horizon, it is easy to fall into despair. It is easy to feel small, blind, and helpless. It seems the universe is mocking us. It beckons us with infinity, but allows us to see only pitiful crumbs. We will never see the edge of the cosmos. We will never know what lies beyond the horizon. We will never see 99% of reality. But in this limitation lies a strange, almost frightening beauty. Think about this. The fact that we see anything at all is a miracle. Atoms born in the cores of dying stars came together to create an eye capable of seeing and a brain capable of wonder. We are the universe's way of looking at itself. Yes, our view is limited, but it is this limitation that makes our gaze so valuable. We live in an era when the sky is still full of lights. We are the keepers of the cosmos's memory. If we are right, and in the distant future, the universe plunges into eternal darkness and loneliness, then our civilization, or any other living in this era, plays a unique role. We are the only witnesses. We are the ones who managed to see the fireworks before they went out. We are the ones who managed to record the history of the Big Bang before the pages of the book crumbled to dust. Our knowledge is incomplete, yes. It is fragmentary. It is built on shadows and echoes. But it is all we have. And it is all anyone will ever have. Instead of lamenting what we do not see, we should be amazed at what we have managed to discern through the crack. We discerned that space is alive, that it breathes and grows. We found ghost galaxies hiding in the dark. We calculated the invisible skeleton that holds the fabric of creation. We realized that we are moving. Humanity stands on the shore of an infinite dark ocean. We have only a small flashlight. Its beam is weak. It picks out of the darkness only the foam at our feet and a couple of stones. We do not see the bottom. We do not see the opposite shore. We do not see the monsters in the deep. But we continue to shine. Not because we hope to illuminate the entire ocean, but because as long as we shine, the darkness is not absolute. Every time an astronomer points a telescope at an empty patch of sky and takes a picture with a 100-hour exposure, it is an act of rebellion. It is a statement. I know you are hiding, but I will look anyway. And perhaps that is the point. Not to see everything, but not to close our eyes, even when the light is fading. We have seen less than 0.01% of the universe. This is true. But that tiny, vanishing, barely visible percentage, it is beautiful.